All right, I'm going to explain monads, but first I need to explain to you what functors are. All right, so to explain what actually monads are, I need to start by explaining what functors are, what applicatives are, and finally what monads are. All right, so let me just create a folder called monads. And let's actually open the interpreter directly. And let's talk a little bit outside of the code. So you have already used something like functors in Python, for example. So the definition of a functor is it's anything that can be mapped over. In Python, what you would do, for instance, if you want to create a list, and that list can have different numbers, and you want to loop over that, so you would say for x in list, and you want, for instance, to multiply each item in that list by 2. So you would print x multiplied by 2. You will hit enter and you have 2, 4, 6, 8, 10. It took each item in that list and applied to it the operation, the multiplication by 2. The same thing in Haskell. You can have the same thing, but instead of doing a loop and all of that, you can have it on one line using something called fmap. And this is a functor. This is the functor example in Haskell, something called fmap. So what fmap does actually, that it takes the function of multiplication by 2 and apply it to the value of whatever the value that you want to multiply by 2. So you would do something like fmap, the operation is multiplication by 2, and you would do here just 10. And just, by the way, is a data constructor, and it's part of maybe type. And I'm going to give you more context about what just is, what maybe is in a moment. But for now, let's hit enter and you have here just 20. Makes sense, right? It has mapped the multiplication by 2 to whatever the value that comes after just. And maybe itself is a type in Haskell that represents an optional value, from where comes the name actually, maybe. So maybe there is a value and maybe there isn't a value. Something that might exist or might not exist. All right, so that's what it is. Just is part of maybe. Just is the confirmation that there is a certain value. It's more of assertion that there is a certain value. So we can say just John. That means that this variable has a value for 100% sure, a value of a string called John, for instance. All right, could be a string, could be integer, could be a boolean, whatever. And this concept might seem foreign to you if you come from Python background or JavaScript background. So always keep in mind that there is just, and just is part of maybe, and just is 100% confirmation that there is a certain value. Why there is something called maybe yes, maybe no? This is for crashing, for error handling. So, you know, to just have safe code. If there is something wrong, we know that maybe yes, maybe no. So if maybe no, in case of failure, the program will not crash, for instance. So I'm trying to simplify things as much as I can for you guys. I know that a lot of you don't know much about functional programming, or, you know, as I said, come from Python, JavaScript, Java backgrounds. So I'm trying to do my best here. If you still have questions, feel free to write them in the comments below. I will do my best to answer all of the questions. All right, so that's as far as the fmap. That's the functor. If you try with something like nothing, for example, if you would do fmap plus 3 in this case, plus 3, right? And you would do nothing, you will have nothing. Makes sense, right? Nothing is the equivalent of none or null in other languages like Python, JavaScript. If you would do the same, just to show you, just 100, for instance, you will have just 103. All right, so that's what functor means. It means that you can apply, or it can apply a function inside something without changing the structure itself. So you have here just, and you have resulted in just. But the value here has changed from 100 to 103 by increasing that value in that function right here. So that function has been applied to that value and resulted in a new value without changing the structure itself. All right, hopefully that makes sense to you guys. Now let's move on to the second step, or the next step, which is applicatives. Applicative takes functor one step further. So let's say that you want to map a function to a function, not function to a value. What can happen in that case? Well, here comes the role of the applicative. All right, just to show you in a practical example, we can do just multiplication of 10, and that is going to be applied to just with a value of 2, for instance. And if you will hit enter, you will have just 20. So the philosophy is the same. You're applying something to something without changing the structure of that thing, right? Bluntly speaking. And that's going to work the same way if you would do just 15, for instance, applied to nothing. You're going to have nothing as well. Hopefully that makes sense to you guys. So think about it as a box. As a box. You have a box and you have different values here, or one big value, for instance. And you want to change. You want to change that. So you have a function of a, for instance, and you want a b, for example. You have input argument of a and you want the result b. So you would apply actually a functor to change the value of 10 to be 20 without changing that structure of just. Don't overcomplicate things. I know I'm repeating it so it looks difficult, but actually it is that simple. It's like that. Just 10, it becomes just 20 by multiplying, by mapping that multiplication of 2 to it. The same thing goes for the applicative, but you take just 10, that function, and you apply it to just 2 with the value of 2, you have just 20. In case of nothing, that's going to give you nothing. It's going to return nothing. And also, for your information, there is a keyword called pure. Pure can actually lift regular functions into the applicative world, right? So you can say here pure with the plus sign or the division sign. Let's change a bit. Pure division. And you want to apply that for here just 10, for instance, and that's going to be applied to just let's say 5. So you can have 2. You should have 2. You have applied the division to the 10 to the 5. That means that you took the 10 and divided it by 5. Now here comes the main protagonist, monads. Monads is the third step after functors and applicatives. So, as we said, functors lets you map a function over wrapped values. Applicatives lets you apply a function that's also inside a box, so to speak, to a value in another box. Haven't we done that? Just multiplication of 5 applied to just of 10, for instance, you have just 50. All right, applying a function that's inside a box to a value that's inside another box. Now, monads lets you take a value from one box, use it to create a new box, and then flatten the result into a single box. I know I'm talking gibberish. I'm going to show you. Just keep in mind that what we do is chain operations that each return boxes. You chain operations. We're going to use this. And notice that this is basically the Haskell logo, if you haven't noticed. Now, let me give you a very good analogy. Let's take the box factory, for example. Let's have a factory that manufactures boxes. So imagine that each computation is a factory that takes raw material and returns a box. With functors, you can paint the box. With applicatives, you can combine boxes. With monads, you can open a box, look inside, decide what to do next, and produce a new box, all while keeping the box system consistent. Did you get the idea? So instead of stacking boxes inside boxes, the monad quietly flattens everything for you. Let's take the cooking recipe, for example. Each step in a recipe might fail. Maybe the egg cracks wrong. Maybe the oven's off. Maybe whatever. So let's say, for instance, we're going to crack the egg, right? And we will need for that the eggshell, and maybe we will have the egg. The next step is that we're going to fry the egg. And the frying of the egg, maybe finally we will have the meal. And we will serve the meal into the plate. So we will need maybe a plate. So meal, if successful, we will need a plate. Right? So we are chaining operations, and basically each step depends on the previous one succeeding. So with monads, you can chain all of that very, very cleanly, not like this. So you would say breakfast here, and we have eggshell and maybe plate. So breakfast shell is equal to, and we'll say here just shell binding crack egg binding to fry egg and binding to serve. All right. Do you see how things are easier here with monads? So you are chaining operations, basically. This, then this, then this, then that. And if any step fails means nothing, in this case, the whole chain short circuits automatically. And that's what this bind operator does that. It unwraps the maybe, runs your function, and keeps the wrapping consistent. You can take a look to monads definition on Wikipedia. There's no problem at all. Try to understand also on your own. You will find here that it tells you that in functional programming, monads are a way to structure computations as a sequence of steps where each step not only produces a value but also some extra information about the computation, such as a potential failure, non-determinism, or side effect. All right, so let's write a very quick example just to wrap up this video, and let's have a monad example using maybe. So for my example, I'm going to check out for safe division to not be able to divide by 0. So safe divide, I'm gonna call that. So safe divide here is the name of the function, of course, and double column, that this means has the type of. So this has the type of. We have here float, and maybe float. What exactly does that mean? So float, maybe float, this describes what types it takes and returns, simply. Okay, so it means safe divide takes two float numbers here, two float values, and maybe it returns a float. It takes two different arguments and maybe it returns the result of the same data type, which is float. And here what's very interesting, if the divisor, so save divide, if the divisor is 0, I want you to get me nothing. Otherwise, I want you to return the result wrapped in just. So I would do save divide x and y equal to just x divided by y. All right, so the first line is I'm defining that function. I want two different floating numbers and maybe I will get a float. The second line tells Haskell to if you find 0, I want you to return nothing. I want you, the third line, which is otherwise, I want you to take x and y and divide them and wrap them in just. Now let me save the file. Let's go to the interpreter and let's load the file. The file is called main.hs. Compiled, awesome. Now let's put monads in test and try to chain two different divisions safely. Now step 1 is just 100. Step 2, I want to divide by 2. So we should have just 50. So to do that, I'm going to have here /x. I want to invoke the function which is called save divide, and x here is 2, so that's the second division, that's the second operation. So the first operation is just 100, the second operation is the division by 2 here, and the third operation is I want to divide by 5. So I will take 100, I will divide it by 2, that's 50, and then I will take the result, which is 50, I want to divide it by 5 to get 10. I'm going to divide here by y, that is the second float, and y by 5. But of course, I will need to bind everything. And here comes our operator, our binding operator, which is this beautiful Haskell logo. All right, remember that. All right, hit enter, you will have just 10 as a result. So again, why 10? Because we have taken 100 divided by 2, that's 50. Then we took the 50 divided by 5, that's 10. And if any step returns nothing, by the way, the chain stops immediately. And let's just try that out. Let's say just 100 binding this operation x, invoking the save divide function, x is 0 in that case, binding with the y save divide y 5, we should get nothing. And there you go, the chain has stopped immediately. It didn't continue further, it didn't go to the 5, because once it has returned nothing, it will stop the chain. So I hope that this was clear to you guys, and that at least it made more sense to you what monads are, also functors and applicatives. And yeah, with that, thank you so much guys for watching. Don't forget guys, if you have any questions, anything at all you need to say, just say it in the comments below. Don't be shy, I will do my best to answer all of your comments. And yeah, thank you so much one more time for watching, and I will see you in the next video.